Welcome back for lesson 9.3. We are still building on our concepts of hypothesis testing. And just like in confidence intervals, depending on the situation, we're going to use a different distribution to help us do some comparing to the proper curve. So if you're testing a single population mean and we already know the standard deviation, we're going to go ahead and use the normal curve. And we're going to use a normal curve with the mean and then the adjusted standard deviation, where we take the standard deviation they gave us and divide by the square root of n, because remember, we're talking about a sample. The population parameter is mu, the estimated value for the point estimate is the x bar, the sample mean. Okay, so this is situation one. Situation two is if you are testing a single population mean and the standard deviation is unknown, the distribution for the test is going to be the t distribution with degrees of freedom equal to n minus 1, just like we did in chapter 8. And then the third situation is if you are testing a single population proportion, the distribution for the test is always going to be the normal distribution, but we're going to use our p hat, our p and our p hat, and then our standard deviation is the square root of p times q divided by n. Okay, so our point estimate is the p hat, where it's the sample x over the sample size n. And we're just going to look at a couple pieces where we decide on the distribution, and then we're going to move on to 9.4. So it says, which distribution do you use when the standard deviation is not known and you are testing one population mean? And we're assuming our sample size is large. So if standard deviation is not known and we're testing a mean, we're going to use the t with alpha and degrees of freedom. What about if a population has a mean of 25 and a standard deviation of 5? The sample mean is 24 and the sample size is 108. What distribution should you use to perform a hypothesis test? So because we know the standard deviation, we are going to use the normal with the mean x and then the standard deviation of x divided by the square root of n. Because we know the standard deviation. Okay. Example 3 says, you are performing a hypothesis test of a single population mean using a student's t distribution. What must you assume about the distribution of the data? So we are assuming we don't know the standard deviation, because that's why we're using the t distribution. Example 4. You're performing a hypothesis test of a single population proportion. You find out that NPQ is less than 10. What must you do to be able to perform a valid hypothesis test? So NPQ less than 10, we need to increase our sample size. Because this ensures when it's greater than 10, ensures normality. The distribution is normal. So you have to pay attention to that. So again, our three distributions are, if we're talking about population means and we know the standard deviation, we're going to use a normal curve. We're going to use a normal curve if we're talking about proportions. So those are the two times we're going to use a normal curve. And if we are talking about the mean and we don't know the standard deviation, then we're going to use the t distribution with the n minus 1 as our degrees of freedom. Okay. So as we move along, you're going to want to make sure that you have your Desmos open because in Desmos, the links in Canvas, there's going to be the computer program in Desmos that is for means and quantitative data. And it's the one where we put in for the confidence interval. But now instead of the confidence interval, we're going to be looking at right here where I've got my mouse. We're either going to be looking at the true mean is greater than 0, the true mean is less than 0, or the true mean is not equal to 0. Okay, and you can see here where my graph is changing on these. Okay, so and then we're also going to look at one with this, which is proportions as well. And then again, we're not going to be choosing the confidence interval. We're going to be choosing this is the greater than, this is the less than, and then this is the not equal to. And we're gonna practice this in lesson 9.5. So catch me back for lesson 9.4, and we're going to keep moving forward.